Thanks a lot. Today we're going to talk about how we can build the DSLs in Kotlin, and the goal of this presentation is twofold. Because, well, first of all, of course, I want to show you how to create DSLs in Kotlin, but I also want to show two of my open source libraries. So that's why this presentation came about. So I actually have two goals with this talk. But I just want to start off by asking everyone here, who would say that you are familiar with Kotlin already, like you know the syntax a little bit, or perhaps have played around with it. Okay, so maybe half. I would have hoped that everyone knew it. Now I have to speed up. The agenda will look like this. I will have a short background of why I'm here and my experience with Kotlin, and then we're going to have a very brief introduction to Kotlin. My goal was to have a little more or lengthier introduction to Kotlin, but I will cover the basics, and then we'll go into what is necessary to understand the code examples that I will show later, or the DSLs. And we're going to look at what I refer to as Fluent DSLs, and we're going to look at the Awaitility open source library for that, and then we're going to talk about more Kotlin specific DSLs, also referred to as type-safe builders, and then we're going to look at another library. So a little background. I work as a developer at Parkster, and it's this digital parking service. You use it as an end user to start and stop your parking. I don't know, maybe you've heard about it or even used it. Instead of going to the parking meter, you can use the app. We're mainly using Java. We are, like everyone else, using microservices. But I was actually here about a year ago, I think, and had a talk about Kotlin. I think it was called Exploring Kotlin or something like that. And it was quite a lengthy talk. I was actually thrown out, I think, at the end. But so I will have to keep this shorter, and I will try. But since then, we have actually put Kotlin in production in several services, and I think we are very happy with that decision. I mean, for me, I think Kotlin has been one of the easiest languages to learn, and I think that's one of the strengths of Kotlin. And it works really well with the existing tools like Spring Boot or whatever, which is also really nice. But talking about Kotlin itself, it's a statically typed language. It features like both object-oriented and functional constructs in the language, like most other languages today. But I really like this, that it's a pragmatic language. It's not built to enhance the state-of-the-art of compiler technology or anything like that. It's really designed to be pragmatic and easy to learn, and easy to understand and read. And I actually think that's really good. As I just told you, I think this is. I mean, if you've used Java, maybe a bit of Scala and Groovy, I mean, you will recognize most things in Kotlin. But try to keep it easy, and also tooling friendly. This is, of course, if you're used to IntelliJ, then Kotlin works really well in IntelliJ. And it has some cool stuff like you can easily avoid having null pointer exceptions, which is actually quite a big deal. It's really quite nice when you start to use that. But we are going to look at some code examples just to get a feel for Kotlin, for those of you who haven't seen it. And you can raise your hand if you have any questions throughout the presentation, and we'll see if I have time to answer. But we're going to look at some functions and variables and some basic stuff, and then we'll, throughout the presentation we will look more at extension functions, something called infix functions, and function literals with receivers that can be used for building these DSLs. But let's first look at how we can define a normal, standard function in Kotlin. And do I have a mouse pointer? Yeah, look. It's nothing really special. It's you type fun and then the name of the function, and then the argument types is they're on the right side of the argument name. It's a little bit different than in Java and Groovy, but this is the way that you declare them in Scala as well, for example. And then you specify the return type afterwards with a colon, and then it's just return a plus b. So it's you should probably recognize this. But there's one little nifty thing, like if you have a function like this, and this is actually called an expression function, because it only, it's just a single expression. And if you have that, you can get rid of these curly braces. You don't have to specify return, and you actually don't have to specify the return type either. And that is regardless if it's an expression body or not, actually, because the compiler can infer the type of the function usually. So you can write it like this, and that can be quite interesting because everything in Kotlin, I think, is an expression. So if you have like an if in Java, the if is a statement, which means it doesn't return anything, but in Kotlin it returns, which is really good, and everything behaves like this, like try and when and other things in Kotlin, which is quite nice. So defining variables looks like this. You have val and var. So val is if you want an immutable reference. So here you cannot change a, and this is checked by the compiler. And here, when you declare it var, you can change the variable later. This is essentially the same thing as final in Java, which means that if you have you can have a mutable array here, for example, and change the content of the array, even though it's declared val. It's just that the reference is immutable. And then this is one of the strengths with Kotlin, because if you don't declare the types with a question mark at the end, they cannot be null. And this is enforced by the compiler, unless you interact with some Java libraries. And it may still work if you have some annotations and stuff on the Java libraries, but then there may be cases when the compiler can't figure it out. But if you're only using Kotlin, this is guaranteed by the compiler, which is really good. You have to handle the null cases. You're forced to do that, and you can be. It's really. I mean, when you reason about the code as well, it's really nice. You know that this is a string. It's not null. You don't have to do null checks all over the place. This is. I've included this in the intro because I think this is really cool. It may not be something that everyone would include in the intro, but I think this is a really good strength, that you don't have to declare classes for everything. Like in Java, if you have a utility function, you often create this some utility class, and you put the function in this class. But often you don't need a class. So in Kotlin, you can just put functions inside a package. You don't need a class, and you can have multiple classes and multiple functions, of course, and also properties inside functions directly. They don't have to belong to a class, which is really. I think this is really good. This is not only for utilities, but also when you model your domain. Many times, you don't need a class. You need perhaps pure functions in a package, and that's it. So I think this is a really good a good thing. Yeah, we need to understand a little bit how lambdas look like in Kotlin as well. So here is a very simple example. Here we just create some array, and then we want to sort it by something. So this is a lambda expression in Kotlin, and you probably recognize this from other languages. It's very similar. And yeah, you can be explicit here as well, declare the type of the name, but you don't. This is inferred by the compiler most of the times. But Kotlin also have something called an implicit parameter, so you don't have to explicitly declare the name. So sometimes it's perhaps obvious, like okay, it's just more things to write if I declare, for example, the name here. You could argue that. So then you can just write it instead of having an explicit name, which can be quite nice. And this, I think they've taken this from Groovy. Groovy has the same thing. In Scala, it's something else, underscore or something. Yeah, and this is also a thing that is, I think, stolen from Groovy. If you have a function like this that takes another function as an argument, and this argument is the last argument of the function, like in this case. Yeah, here we have the function do with text, and we take a function that expects a string and then returns a string. We could write it like this: do with text, we pass in a string here, u1, and then our lambda expression like this. But then there's a nifty little thing that you can do. So you can do it like this. So you actually can write the lambda expression outside of the parentheses. So it makes it a little bit nicer to read. And this is also something that you can use when you create APIs or DSLs, which just makes it look a bit nicer. Yeah, so now that we know Kotlin, we can move on to look at the first kind of DSL or API that we will explore. And for that, we're going to look at a library called Awaitility, which is a Java library that allows you to express expectations of asynchronous systems. So here's an example in Java. So here we can imagine that we have some command publisher or something that publishes a command somewhere, register user command. And yeah, as it says here, this is potentially a long-running process or something. Maybe there are many event or command handlers involved in this process. But in the end, we just want to make sure that some user repository that we have is equal to 1. So this is essentially Awaitility, the Java DSL. So you say that you wait at most 5 seconds, and then this condition here should be fulfilled. And then there are some if you know Hamcrest, for example, which is this quite famous matching library in Java, you can make use of Hamcrest matchers if you like, which makes this a bit, because Hamcrest is quite nice when it comes to composability. Maybe you know about AssertJ or something like that, which I actually like AssertJ quite a lot, but when it comes to composing different matchers, then I think Hamcrest is actually really good. But you can use AssertJ as well, or any assertion library for that matter in Awaitility as well. So then you just use until asserted, and here is an example with AssertJ, which essentially does the same thing. But one of the key features of Awaitility is that it should be able to scale in complexity. So it should be really easy to get started, like this. But it should scale to most use cases. So here's an example when it's more complex, with some quite at least more advanced configuration. But it's still like the same DSL, and it's still the same like English-like kind of syntax. You should probably, if you read this, be somewhat familiar with what is what it's doing. like you have a Fibonacci polling interval, you ignore some exceptions, blah blah. Specify some executor service that you want to use when Awaitility polls the condition here, and you can specify some aliases and yeah, a lot of stuff. Yeah, and that is one of the purpose with Awaitility. So Awaitility already has, of course, the Java API, but it also has support for Groovy and Scala. So when Kotlin came about, I thought, well, I should probably try to see if I can do something here to make it a bit more, yeah, maybe even yeah, slightly nicer, perhaps, if that was possible. And before we look into that, we can just see how this actually works, or how it looks like when we call just a normal Java API from Kotlin. You can see that it looks almost exactly the same, which is a good thing. It means that that you can interact with the libraries from Kotlin in a idiomatic way. So this is just plain Java, and it looks very similar. But here we can see, hopefully, if you can read the text. This is an example of the Awaitility Kotlin DSL, and what I refer to as the Fluent DSL. And here you can see it's very similar to what we have here, but arguably even nicer, or at least more English-like. You can see that we've got rid of a lot of parentheses and the dots, which is quite nice. So how does this work? Well, first of all, we have to understand something called extension functions in Kotlin. And this is also one of the strengths of Kotlin. It's super easy to create these kind of extension functions. And that means essentially, if you, for example, in Java, you often have this, you create some utility, so you bring in, I don't know, commons lang or something to get some more functions that you can invoke on lists or something like that. But it would have been more natural, perhaps, to be able to extend list and just invoke the function as you would with the normal functions on the list. And this is exactly what you can do in Kotlin. And the only thing that is different between defining extension functions and normal functions is the class name here. You can imagine here, if you just remove the class name, then you just have a normal function, like how you declare functions normally. So in this case, we extend the mutable list class, which is a Kotlin class, and we declare a function called swap. And that means that when we create this mutable list, we can invoke swap like any other method if we have imported this function into our scope. And that is this is very useful, I think. And this is one of the techniques that I've used in this Awaitility Kotlin DSL as well. I'll show you that in a minute. Another thing that you can do in Kotlin is to define infix functions. And infix functions in Kotlin simply means that here's an example of an extension function again that now happens to be infix, but it doesn't have to be an extension function to be an infix function. But if we create an extension function here with infix as this keyword, then instead of writing like this 1.shift_left2, you can write it like this 1.shift_left2, but without dot and without parentheses, which is quite cool. And that's essentially what you need to create something like this. At least if you have an existing Java API, perhaps that you want to make a little bit nicer, arguably, then these are the two things that you need. You need extension functions, and you need infix functions. And here is this is the actual source code from Awaitility, or some parts of it that I've taken a screenshot of. And here you can see what happens when you call this await function here. It's that under the covers something called condition factory will be instantiated and returned. This is what you evoke functions on configure it. So here we simply create an extension function of the condition factory. That is, yeah, we have infix. Okay, and everything. The only thing we do here is that we, and this is an expression function as well, so we don't have to specify color braces. And yeah, this is, perhaps I should explain this. We now, when we are here, we are actually in the scope of the condition factory instance, which means that we could say this.alias here, because that we call the alias function inside the condition factory instance that we're in. But since this is implicit, we don't have to explicitly call this. So this actually calls alias on the instance of condition factory that we are extending. Yeah, and that's it. So this is what allows us to write with alias without the dots and the parentheses. Yeah, and that was the first part, and we are on time, I think, which is good. Now we can actually take questions. This is great. But since it's so easy, we can continue. This is probably going to be a little bit more complex, I think. Okay, so the other library that we will look at is called Kystrix. And it's, again, just a wrapper over an existing library called the Hystrix, which is this a library from Netflix for handling latency, and fault tolerance in distributed systems on the JVM. I don't know, are you familiar with Hystrix? Yeah, good. Actually, yeah, I've forgotten that I actually had this slide. Yeah, that's good. Yeah, so Hystrix is good. If you have like a request to one system, of course you should try to not do this. Actually, you should try to minimize the number of calls you make between systems, obviously. But this is just an example. So here you get a request from the client, and for the client to return something, or sorry, for this system to actually return the result that the client expects, it needs to call system 2. But system 2 needs to call both system 3 and system 4, and system 3 needs to call system 5. And then everything returns here, and then you get a response back to the client. And well, there are many things that is potentially bad here, but one really bad thing that can happen is perhaps if system 3 here, maybe it crashes, or maybe it's slow, maybe it does some horrible GC or something, since it's Java. It may happen. So that means that system 2 will become slow as well. So because this system is slow, it could be so slow that it actually crashes, which if system 2 does not protect itself, it may also crash, which means that this system will crash. So it's to prevent these cascading failures, we can introduce Hystrix, if we like. So this is what Hystrix does. And then you're correct. Isn't this this is a good question to ask? Isn't this 2018? Shouldn't we all be migrating to Kubernetes and Istio and Linkerd or something like that? And yeah, maybe we should. But it's still like still early days. I mean, Istio went to 1.0. It wasn't that many months ago. Linkerd was just maybe 1 month ago or something. It went to 2.0. So it's still new, and I think that we're still learning as an industry how we use these tools. And Istio, I haven't looked that much at the Linkerd, but at least Istio is, I think, very complex if you want to understand really what's going on. So it's not obvious at this current stage that you want to bring in something like that. And maybe you want to do it, but maybe you still have your existing applications that may be using something like Hystrix. And maybe you're using Kotlin, you can use this library. So, oh yeah, here you can see, oh, so complex. I don't know what this is, crazy stuff. But yeah, so how does Hystrix, whoa, that was not my intention. Oh, yeah, now we're back. Yeah, so this is Hystrix command in Java. We have some. We first of all we extend from Hystrix command. So we create our command here, remote API. What we actually want to do is this little thing here. We want to use our web client to get some a list of to-dos from somewhere, from some remote service. That's what we want to do. And if this fails for some reason, for any reason, we return an empty list. So we always return something here. But then, of course, we need to configure like Hystrix. So here we configure some what the command should be called. In this case, what's it called? My command. Wow. And then we have some group key, and this is just a way to perhaps for reporting reasons you want to group different commands together. And then you can specify different thread pools and all kind of things. And here we specify some timeout in milliseconds and how many concurrent requests are we allowing here in this Hystrix command. And if we're filled up with there are more than 3 requests, how many can be queued before we just fail fast. So this is essentially how it looks like, and once you have created this, you can invoke it like this. You just new up the remote API command and then call execute. So this is how it looks in Java. If you go to plain Kotlin, it looks like this. This is actually quite nice. Yeah, at least if you compare it to it's not that horrible in Java either, but here is at least more succinct. Here you have the this is an expression function again, so you don't need the curly braces and stuff like that. And here you can actually see a small little thing, but the retrieve function here, if you compare that with Java, you see here that have you seen this in Java? Some libraries like Jackson, for example, you need to do this kind of hack. Because we don't have real generics in Java, we have these erasures, so they the generic information is lost or can be lost at runtime. So this is like a hack that you do. Typically, when you have a library that is written in Kotlin, you don't have to specify that, because Kotlin does a lot of magic stuff under the hood to make this work using reified functions that you can declare yourself as well, and this can be useful when you're building DSLs for APIs as well. But I won't show that. But it can be interesting to know, and this is quite good. Yeah, so it's kind of similar, but less verbose. And in Kotlin, it looks almost the same as in Java when you invoke it. You don't have the new keyword in Kotlin. You just invoke it like this. So let's look how this how Kystrix looks like, and it looks like this. And it's actually more lines of code, but I would still argue that this is easier to read if you compare to this stuff up here. Oh no, now I'm way ahead of myself, I think. Okay, now I'm back. Yeah, but here essentially you specify the group key if you like, thread pool key, the command, blah blah blah, the fallback, and then properties of different sorts. And this is and this is of course type safe, which is pretty cool. I mean, you get help from the compiler here. I think this is also inspired by Groovy. They have something similar. I don't remember what it's called in Groovy, but you have something similar. But then it's not type safe. So this is pretty cool. You can imagine that you can build all kinds of stuff with this, and people have done that as well. But yeah, how does this work? Yeah, and so in order to understand that, we need to dig a little bit deeper. So here we have this is a normal function again that just takes a function as an argument. And in this case, it's an int, and it returns a string. And the only thing it does is that it calls the function with 5 as a parameter. And if we print that and we pass the lambda expression, the number is, and now we use the implicit parameter here, it will print the number is 5. And this we know already. But now it becomes pretty cool. If you change the signature here a little bit. This is what's referred to as function with the receiver, or sometimes function literal with the receiver. So you change, essentially you take the parentheses here and move them to the right of the type, and then you insert a little dot here. Then you can do like this. This is a bit subtle here perhaps, but here's the difference. Here you did it, and here you can do this, because what happens here is that when you invoke your Lambda function, the integer will actually become this in the scope of the Lambda, which is not the case here. Here the integer will be it. It's not really the same. And if we look at the next example here, we can perhaps begin to understand the coolness of this. Because now if we want to take the number and multiply it by 2, so this is a standard function in Kotlin. If you have an int, you can do times 2 on the int, or times whatever. Look, here I just do times 2. And this works because this, in this context, is actually the integer that we pass in. And that's the little trick you have to remember. And yeah, okay, now I remember this. This is a class in Kotlin. This is a command from Kystrix called the Kystrix command, or sorry, a class from Kystrix called Kystrix command. And here you can see the group key, command key. This is what was actually invoked from here. When you do this, you actually you actually call these functions here. But how does this work? So let's see how it works. So here we imagine again that you, as a client, you just call a function to get started with everything. So the function that we invoke is this function here. Now we're inside the Kystrix library that you've imported this function somehow. And then we look at the signature. Here we have a function, but here instead of f, I call it block. But now it takes a Hystrix command, and now it's this special kind of function. So it's this function with receiver. So it takes an instance of that and doesn't return it. This is void in Java, like it returns a unit, nothing of interest. So what we do here inside the function scope of Hystrix command, we create a new instance of the command that we saw in the previous slide. And then now comes the cool thing. Now we just call the function with this instance, which means that on the client side, we are now inside here, inside the scope of this Lambda parameter. And it has just received an instance of Kystrix command. And Kystrix command contains the function command and other things like group key and stuff. And since this is implicit, you can just call the function like this. And that's how it works. Yeah, so now the client will just continue configuring everything, and once that is done, we can just we invoke some hidden build function here, and then we just execute the command like we would like when you executed normally or manually before. What do I want to show here? Oh, yeah, this is cool. I don't know if you can recognize that yet, but if we go back, sorry. Well, yeah, if you look at this, command properties or thread pool properties, maybe if we go even further back, maybe you recognize some of the names here. You recognize perhaps with execution time out in milliseconds. You see here? With execution timeout in millis. So now you're obviously asking, have I duplicated all of these functions in this DSL? And the answer is no. Because this is also just an animations. This is also just this function with receiver. But now I just create an instance of a class that I don't own. But it doesn't matter, I don't have to own it myself. Which means that if Netflix decides to add more functions, you can just use a later dependency, and you can code complete these new functions as well. Which is this is cool. Yeah, I don't know what I want to do here. yeah, so that's how you can do that. And yeah, there are more stuff that you can do with these type-safe builders. For example, now that I have a few minutes, I can actually tell you about that. What the? You always regret adding animations. Yeah. So here, there's a little thing here, because when you just create your type-safe builders, like I've shown you here, you can actually invoke, if you're inside this scope here, you can actually invoke this function, group key, inside this scope here, which is not what you want to do. You just want to be able to invoke these functions here. And then there is a little trick. You can use this DSL marker on various places, and then Kotlin will figure out that these are in the same scope or two different scopes. So that's one thing you can read up on. Yeah, and I'm just going to show you. Yes, so now that you're all excited over Hystrix and Kotlin and everything, what else can you do? That's a good question. Because if you've used Spring 5, maybe you're familiar with this new web Flux and stuff, Mono and Flux, which is non-blocking, blah 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 blah. And we're using this at Parkster, so I obviously had to add support for that as well. Yeah, exactly. So I've created some. This is actually another library that's built on top of Kystrix. With these extension functions. So instead of having a command here, you can use mono command instead, if you have a web client that returns mono. And then you can convert it back easily to a mono as well in the end. And this also works for, whoops. Yeah, now I give up. Yeah, it works for Flux as well. Okay. This is good. I'm on time, I think. Yeah, so as you've hopefully seen, Kotlin has support for pretty nice support for type-safe DSLs in both this kind of Fluent manner and the type-safe builder style. And yeah, I know you want to run home, skip the pizza, and download and play around with these projects, but I have links for you here that you can memorize instead, so it's okay to have a pizza. Yeah, Hystrix, I blog here sometimes. Do you have any questions? If not, I think it's pizza. It's double wow that I'm actually in time.